Hi folks, so we have talked about, sorry about that, we've talked about vertical stretching and compressing and vertical shifting. We've also talked about horizontal compressing and stretching, which is, how we change the period of a sine function or cosine function. Now we want to talk about how we can deal with our horizontal shifting. If you remember from our previous discussion about transforming functions, horizontal shifting, when combined with horizontal stretching and compressing, gets a little confusing. Same idea when you combine vertical stretching with vertical shifting. So let's take a look at this example here. Y equals sine of 2x plus pi over 6. So of course our parent function is going to be the sine function, y equals sine of x, which I've drawn here in red. Okay, so there's two ways you could go about this. You could deal with the shift first or the stretch first. Alrighty, now with the computer, it's going to be hopefully easier to see, but I don't want us to forget kind of what's going on behind the scenes. So let's pretend I want to deal with the stretching / compressing first. Okay, so let's see, I'll replace x with 2x, and so now, let's see, since this would be, the graph is going around this, my angle is increasing twice as fast as it normally would, to squish it inward, because again, we don't need as much time to get through one full revolution. And so if I replace x with 2x, that's what we see here. The new red graph, the new parent function, is just the original one smushed inward. So its period now is only, instead of 2 pi, it should be just 0 to pi right there. Okay, so we'll treat this like our new parent function. The one part we want to remember, folks, is that when I'm doing this shift, you are replacing the actual input x. Okay, so I can't just replace x with pi over 6 because, and we can see here what's going to happen, I replace x with x plus pi over 6. We saw what went wrong before in the video of Mr. Chu, is that if I did this, then well, okay, we get a new graph, 1, so this blue graph is the red graph shifted over pi over 6, and we can see that here. From the origin, we now end up at negative pi over 6, 0. However, if we were to distribute this graph would actually be, well, let's see, 2 times x is 2x, and then 2 times pi over 6 would be, well, 2 pi over 6, or pi over 3. But that's not the graph that we're looking for. Sorry about that. That's not the graph we're looking for, right? So we need to go back to the drawing board. Okay. Well, since again I'm replacing the actual x right here with some shift that's going to end up resulting in 2x plus pi over 6, I need to figure out, okay, well, what times 2 will get me to pi over 6? That answer would be what pi over 6 divided by 2, which would be pi over 12, right? And we can see here, oh, hey, look, when I distribute this, I will end up getting sine of 2x plus 2 pi over 12, which is simplifies down to pi over 6. And so if I see here, hey, you can kind of see it a little bit. You can see the color changing on this one. Actually, why don't I change this like so? And now you should hopefully be able to see here the graphs overlapping. So this graph and this graph are exactly the same. Okay, but let's pretend we want to go about another way. Okay, so I start off with my sine function. Let's pretend I want to deal with the shifting first. That's fine. So I'll do, y equals sine of x plus pi over 6, which we know shifts it to the right. Sorry, to the left, excuse me. Again, we shifted it to the left now. Totally fine. Okay, and now if I want to deal with that compression, remember, you're just replacing x with 2x. That's how the transformation works, and we talked about that in, again, that previous video months ago. And so now, if I do this, y equals sine of just 2x plus pi over 6, I will end up exactly with the graph that we were looking for right here. Okay, but I do just want, alrighty, one last thing I want to observe here is the difference between the final graph and the graph after you've dealt with the horizontal compression. Okay, so I'm not comparing it to the parent function y equals sine of x. I'm comparing it to just the graph after we've already handled that horizontal compression in this case. So the question is, how much did we actually have to shift it? Well, we can see here that we had to plug in not pi over 6, but pi over 12, and we can see that graphically here, where our reference point here at the origin gets pushed over to the left at pi over 12. And so this is what we call the phase shift, and that really is just a fancy way of saying the horizontal the horizontal shift. The reason we wait until after we've done with the compression is because we can see here on the parent function that the shift is not consistent all the way through, right? Because we can see here, okay, these 2 points are pi over 12 away from each other, but from this point, this peak to this peak, it's not pi over 12. And so we wait until after we've dealt with that compression to determine what that shift is. Okay, we can see here the shift is this, just whatever this number was divided by whatever this coefficient was. And so we actually have now all the things we need to kind of summarize everything we need to know about transforming trig functions. So I'll kind of just draw it right here. So our general sine function or cosine function or any trig function really is going to look like this. So we have a times sine of the argument inside would be omega x minus phi, or phi. I like to say phi, but I think it's actually called phi. And then plus b. So remember that the a is the amplitude, so it tells you how far up and down your graph will go. We can see the effects here. If I change this to 7, oh, sorry, let's change this one. We'll start with this one. If I change this to a 7, then our graph obviously gets much taller. If I change b by saying subtracting 3, it pushes it downward to it changes our midline, right? So that midline happens at y equals b. We saw here, whatever this stretch factor does or is, it changes your period. So the larger this number is, the shorter it shrinks your period. And then also our phase shift, if we factor out an omega, then we will end up with something like this, where we can see that phi over omega is how far we're actually shifting that graph. And so that is, again, the phase shift. In the next video, we will see an example. And so thank you for watching. Hopefully this made some amount of sense.